Hello and welcome. I'll be answering Jamb 2010 physics part question 2. Two cars moving in the same direction have speeds of 100 kilometers per hour and 130 kilometers per hour. What is the velocity of the faster car as measured by an observer in the slower car? So this question is under relative motion. Okay, so under the subtopic of motion known as relative motion. And in relative motion, you are basically describing the motion of one body with respect to another. So as you can see in the question given to us, we are asked for the velocity of one of the bodies, that is the faster car, as measured or with respect to the other one, that is by an observer in the slower car. Now we are given the velocities 100 kilometers per hour and 130 kilometers per hour. So obviously the velocity of the slower car is equal to 100 kilometers per hour, and the velocity of the faster car is 130 kilometers per hour. Now, in terms of relative motion, if an observer is in the slower car, okay, and they are moving in the same direction, and you are asked to find the hour. So for an observer moving in the slower car in the same direction as the faster car, the velocity of the faster car with respect to the slower car, you know, the slower car is already moving at a velocity of 100 kilometers per hour. So it's like asking by how much or how fast is the faster car in comparison to the slower car. So the faster car only exceeds the slower car in terms of velocity by just 30 kilometers per hour. So that is the correct answer to this question, option D. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 physics past question 4. A stone and a feather are dropped from the same height above the Earth's surface. Ignoring air resistance, which of the following is correct? A. The stone and feather will both reach the ground at the same time. B. The stone will reach the ground first. C. The feather will reach the ground first. D. The feather will be blown away by the wind, while the stone will drop steadily. Now, there are some things to take note of here, okay? First, you are looking at acceleration due to gravity. Acceleration due to gravity. So now you have two objects, a stone and a feather, okay? Now another thing to note is that they both have what? Different masses, okay? So obviously the stone is heavier than the feather, and they are dropped from same height above the Earth's surface, okay? Now we are asked to ignore air resistance. Now this is the crucial part of the question. Ignore air resistance, okay? So without air resistance, what will happen? Now we said something about acceleration due to gravity. Now basically acceleration due to gravity is constant. Acceleration due to gravity is constant in the sense that every object you drop above the Earth's surface will fall at a particular acceleration, will fall at a downward acceleration that is constant, okay, irrespective of the object. So it is constant irrespective of the mass of the object, okay? So this means that even if you drop a pin and a ball, okay, if you drop a pin and a ball, irrespective of the mass of these two different objects, they will fall at this constant downward acceleration, okay? And that acceleration is approximately 9.8 meters per second square. okay, 9.8 meters per second square. Some approximate it even to 10 meters per second square, but that acceleration is constant. Now if the acceleration is constant, that means the change, okay, in velocity, or the velocity in general, will be constant, okay, because acceleration is a measure of the rate of change of velocity with time. So if they are falling at the same velocity, or as many will call it, as the same speed, that means they will reach the ground at the same time, okay, in an ideal environment. And in this case, in the question given to us, it is an ideal environment because air resistance is absent. So since there is no air resistance, it will fall, okay, under the influence of what, of the acceleration due to gravity, and will fall at the same velocity. So that means that they will reach the ground. This means that they will reach the ground at the same time. Now remember, we said this happens irrespective of the mass of the object, okay? So having established that they will reach the ground at the same time, that is what is seen here in option A. The stone and the feather will both reach the ground at the same time. So option A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 5. A car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? A. 5 meters per second square, B. 25 meters per second square, C. 20 meters per second square, D. 2 meters per second square. So this question is very straightforward. You are asked to calculate the acceleration of a car, and you've been given both the initial velocity and the final velocity, and also the time. Now acceleration is defined as the rate of change in velocity with time, and mathematically acceleration A is given as v minus u over t, where v is equal to the final velocity, u is equal to the initial velocity, t is equal to the time. So the final velocity, of course, is 45 meters per second. Initial velocity is 25 meters per second, and our time is 10 seconds. So you apply that directly into the formula. A is equal to 45 minus 25 over 10. And if you do that, the answer it will give you is 2 meters per second square. 2 meters per second square is the unit of acceleration. So 2 meters per second square is option D. So D is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 6. An object is weighed at different locations on the Earth. What will be the right observation? A. Both the mass and weight vary. B. The weight is constant while the mass varies. C. The mass is constant while the weight varies. D. Both the mass and weight are constant. Now, this is looking at two concepts, mass and weight. Now, in everyday life applications, these two terms are used interchangeably. But in physics, we are made to understand that there is a difference between mass and weight. Now, we are made to understand that mass is a fundamental quantity which is a measure or a function of the quantity of particles or quantity of matter. You can say the amount of quantity of particles or quantity of matter in a body. On the other hand, weight is a function of mass and the force exerted by gravity, or the acceleration due to gravity. Now, weight is usually mass multiplied by acceleration due to gravity. Okay, while mass is just measured using the whatever apparatus, maybe weighing balance or whatever you want to use to measure it. Now, weight, of course, is measured in Newton, and mass is measured in kg, in kilograms. Now, a key observation between mass and weight is that the mass of a body and the weight of that body is different, as we have established, and will have different values. And when you take weight, when you take the weight of a body in two different locations on the earth, there is likely to be a difference in both values. The reason is because acceleration due to gravity varies at various locations or at various points on the earth. So since the acceleration due to gravity will vary, and weight is a function of mass and acceleration due to gravity, when you take or when you weigh an object at different locations on the earth, the weights, okay, will have different values due to this difference in acceleration due to gravity. However, mass remains constant. Mass is constant irrespective of where you take measurements of mass. So if you weigh an object at different locations on the earth, what you would observe is that the mass will be the same while the weight will be different in value. Now we see that here in option C. Option C says the mass is constant while the weight varies. So option C is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 7. So you have a diagram here and we have to use it to answer the question. Now the diagram above represents balls in an undulating surface. Which of the following options represents positions of stable equilibrium? A. 2, 5 and 8. B. 1, 4 and 7. C. 3, 6 and 9. D. 3, 4 and 8. Now you have this diagram here representing balls at various points in an undulating surface. So a surface that is not flat, okay, an undulating surface. Now we are asked for the ones which represent positions of stable equilibrium. Now stable equilibrium, okay, a body is said to be in stable equilibrium if it tends to return to its original position when slightly displaced. So if a body is in a position such that when you slightly displace it, it will return back to its original position, that body is said to be in stable equilibrium. Now let's look at each of the positions in the diagram. Now number 1, or the ball in number 1, is located up here, okay. So what will happen if you displace it? If you displace it slightly, it will fall. Okay, if you displace it this way or this way, for example, it will fall downwards and take rest at a new position. Okay, the same thing applies for 4 and for 7. Okay, so when you displace them, what will happen is that they won't return to their original position. They will just take a new position. So they are not in stable equilibrium. Now ball 2, ball 5 and ball 8 are in similar positions. Now what happens there, when they are displaced, okay, they will also come to rest in a new position, and they do not fit into this definition of stable equilibrium, hence they are not in stable equilibrium. But ball 3, ball 6 and ball 9, what will happen is that when they are displaced slightly, either this way or this way, okay, because of the shape of the surface, they will come back to their original position. They will come, or they will return, okay, to their original position when displaced. So 3, 6 and 9, 3, 6 and 9 is option C. So option C is the correct answer to this question. Now, in addition to what we've just said, usually an example of stable equilibrium that is usually given is a ball in the middle of a bowl. Okay, so a ball in the middle of a bowl, when you displace it, it will return back to its original position. Now you can see the positions of these 3 balls. The shape of the surface looks as if they are in the middle of a bowl, so that's another indicator that they are in stable equilibrium. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 8. A bulb of weight 0.1 Newton hangs from a massless string of length 50 centimeters. A variable horizontal force which increases from 0 is applied to pull the bulb until the string makes an angle of 60 degrees with the vertical. The work done is A. 0.250 joules, B. 0.025 joules, C. 0.050 joules, D. 0.500 joules. So this question is quite long, but compared to the length of the question, the solution is quite simple. Okay, and basically you are asked to calculate the work done. And this work done is work done against gravity. Okay, so you are going to make use of the weight and just the length of the string. So you are not going to make use of this angle with the vertical. These are the only 2 variables you are going to make use of. Now, work done generally is given by mgh, okay, where m is the mass of whatsoever body you are considering, g is the acceleration due to gravity, okay, or the influence of gravity on that body, and h is the height or length, okay, or distance or whatsoever you are considering. Now, in this case, you are using a string, a massless string, and you are given the weight in Newton. Remember, you are given the weight, not the mass. You are not given the mass, you are given the weight. So that is to say, the mass has been multiplied by the acceleration due to gravity to give you the weight. And weight, of course, is considered a force. So F, okay, you can also say F times S. Okay, let's call S, where S is the length of the string. Remember, I said you can, the H here represents, in the root formula, the H represents the height or the length or the distance or whatsoever you are considering. So I have decided to call that length S here using another variable. So F times S. Okay, this is just what we will do. Now, our force has been given to us in Newton, which is the weight of the bulb, and now our length of string is given to us in centimeter. Now you can't make your calculation using centimeter. You have to convert to the SI unit, which is meters, by dividing by 100. So if you divide by 100, it will give you 0.5 meters. So you are all set to apply the F times S formula. So F is equal to 0.1 multiplied by 0.5, and 0.1 multiplied by 0.5 will give you 0.05, okay, or 0.050, and the unit for work done is joules. So 0.050 joules, which is option C, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 9. The surfaces of conveyor belts are made rough so as to A. Prevents the load from slipping, B. Make them stronger, C. Enable them carry more load, D. Protects them while carrying load. So we asked the reason why the surface of conveyor belts are made rough. Now conveyor belts are often found in machines or machines used in industries to convey or to carry certain load, okay, for bearing or carrying certain load. Now this making of surfaces rough is basically based on friction, okay, and friction is more or less referred to as the force which opposes the motion between two surfaces in contact. Okay, so this is what friction is. So of course the conveyor belts are going to be in contact with certain parts of the machine, and hence the conveyor belt is placed there so as to help bear the particular load. Now why are they made rough? Now this is an advantage of friction, and one of the advantages of friction is its use in fan belts and conveyor belts, okay, fan belts or conveyor belts, okay, over wheels or pulleys in machinery. Now the surfaces are made rough. The rough surfaces ensure that there is enough friction, okay, and the reason why there needs to be enough friction is to prevent slipping, to prevent the moving parts from slipping, and as a consequence of that to also prevent the load which the conveyor belt is carrying from slipping. So to prevent the load from slipping is option A. Option A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 10. A machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. Now we're asked to calculate efficiency, and we're given a few data here. Now before we do that, it's important to establish the formula for efficiency of a machine. And efficiency of a machine is calculated as mechanical advantage over velocity ratio times 100 over 1. Okay, so now we have velocity ratio given to us as 6 from the question, and then we are given effort, and we are given the force, okay, exerted by the load, and the force required as the effort to raise this load. Now we need to find the mechanical advantage. Now mechanical advantage is given as the load over effort. So load is 800 Newton, effort is 400 Newton, okay, so the units cancel out, and this will give you 2. So the mechanical advantage is 2. So you can substitute now into the formula directly to calculate the efficiency. So the efficiency is given as 2 over 6 times 100 over 1, and 2 over 6 times 100 over 1 is 33.3. Remember, efficiency is measured in percent, okay, and that was the reason why we multiplied by 100. So 33.3% is the efficiency of this machine. 33.3% is option C. So C is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 12. In a hydraulic press, the pump piston exerts a pressure of 100 Pascal on the liquid. What force is exerted in the second piston of cross-sectional area 3 meters square? A. 200 Newton, B. 100 Newton, C. 150 Newton, D. 300 Newton. So we are looking at a hydraulic press, and a hydraulic press has two pistons, the pump piston and the second piston. Now, for a hydraulic press, the force over area, force per unit area, that is the pressure exerted by the pump piston, is equal to the force over area, the pressure of the second piston. Okay, so the same pressure is experienced across both pistons. So like we said, F, small f in this case, is the force of pump piston. A is the area of pump piston. Meanwhile, capital F is force of second piston, and A is area of second piston. Now, from the question given to us, the pressure exerted by the pump piston has been given to us. So this force over area is pressure. So that is 100 Pascal is equal to force over area. Okay, so the area is given to us as 3 meters square. So that is F. We are to find the force. So F over 3. Now, if you cross multiply, F is equal to 100 times 3, and that is equal to 300 Newton. 300 Newton is option D. So option D is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 13. The accurate measurement of the relative density of a substance in its powdered form is done with a beam balance and A. a Eureka can, B. a burette, C. a pipette, D. a density bottle. Now, we are asked for what is used to measure accurately the relative density of a substance, of a powdered substance. Okay, now it's important to note that relative density is a function of the mass of the substance. Okay, so in order to carry out measurement of relative density, you take mass of equal volume of water in the relative density bottle, okay, and you use it to determine the mass of the substance, the powdered substance. So you are going to use a density bottle, like we said, a relative density bottle. Okay, you use equal mass or mass of equal volume of water in a relative density bottle to determine the mass of the substance. And like we've established, the mass of the substance is equal to the relative density of the substance. And you fill the bottle, the relative density bottle, with the powder and water respectively, and then weigh on the beam balance. So the major thing to draw out from this explanation is that the density bottle is what is used along with the beam balance to measure the relative density of a powdered substance. So option D is a density bottle. So that is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 14. A hydrometer is an instrument used in measuring A. Density of liquid, B. Relative density of a liquid, C, relative humidity of a liquid. D, vapor pressure of a liquid. Now, a hydrometer, okay, is what we are looking at here, and it is an instrument used for measuring the relative density of liquids based on the concept of buoyancy. So basically what happens is that the hydrometer is placed in whatever liquid in which you are trying to measure the relative density, and the hydrometer is graduated. So what happens is that the hydrometer is observed until it becomes stable or buoyant in the liquid in which it is placed, and then the reading is taken from the graduated scale on the hydrometer. So, as we have rightly established, it is used to measure the relative density of a liquid, and that is option B. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 15. One special advantage of alcohol over mercury as a thermometric liquid is its A. Low freezing point, B. Low boiling point, C. High specific heat capacity, D. Low density. So in terms of thermometric liquids, that is liquids used in thermometers, you have for alcohol and you have mercury. So you have mercury thermometers and alcohol thermometers. Now, one of the advantages of alcohol over mercury is the fact that it has a low freezing point. Now, the low freezing point of an alcohol thermometer enables it to measure low temperatures. Okay, so this is one of the importance or the advantages of alcohol over mercury thermometer. So low freezing point, option A, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. This is Jamb 2010 Physics Past Question 16. Two metals P and Q of length L1 and L2 are heated through the same temperature difference. If the ratio of the linear expansivities of P to Q is 2:3 and the ratio of their length is 3:4, what is the ratio of increase in lengths of P to Q? A. 5:7, B. 2:1, C. 1:2, D. 7:5. So here you are looking at linear expansivity, and basically what you are looking at in linear expansivity is increase in length with increase in temperature. Now in this case you have two metals P and Q of these lengths. Okay, now the general formula for linear expansivity is alpha, linear expansivity, equal to L2 minus L1 all over L1 theta, where theta is the change in temperature. Now for this question you are looking for the ratio of increase in length. So let's just say increase in length. Okay, increase in length, and the increase in length is this L2 minus L1, also known as L2 minus L1 is the increase in length. So that is basically what you are asked to calculate. Now if you are to make it subject of formula here from this equation, it means cross multiplying this, that is L2 minus L1, which is that increase in length that you'll be looking for, equal to alpha L1 theta. Okay, so to find this, if you are given these values, that is what you would make use of. Now you are dealing with ratios of two metals here. Okay, so when you are considering two metals, you'll be considering the first one for metal P and the second for metal Q. So okay, so this is obviously for P and this for Q. Now it tells us that the temperature difference, change in temperature, is the same. So if they are of the same value, that means they will cancel out. Okay, so this is the formula you would be left with. Now we can insert our values. Okay, so the ratios of the linear expansivities, that is alpha is the linear expansivity. Okay, so the ratio of the linear expansivity is 2 to 3, and PQ, so 2 okay over 3 multiplied by the ratio of their lengths. Okay, so these are their lengths, that is 3 over 4. Okay, so that is equal to 6 over 12, and reducing this to the lowest term is 1 over 2. Now remember, what we are looking for, of course, is, or what we have been solving for, is the ratio of their increase in length, and we have 1 over 2, so that is 1:2. So 1:2 is option C. So 1:2 is the ratio of their increase in length. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 17. The density of a certain oil on frying becomes 0.4 kg per meter cube with a volume of 20 meter cube. What will be its initial volume when its initial density is 0.8 kg per meter cube, assuming no loss of oil due to spillage? A. 10 meter cube, B. 5 meter cube, C. 8 meter cube, D. 12 meter cube. So we are looking at density, and density is equal to mass over volume. Now for this question, you are working with initial density. Okay, so initial density is equal to 0.8 kg per meter cube. You are looking for the initial volume. So the initial volume is what you are looking for, which is unknown. Then you also have the final density given to you in the question. The final density is 0.4 kg per meter cube. And lastly, you have the final volume also given to you in the question as 20 meter cube. Now you have complete set of values for final density and final volume. So to solve this question, you will find the mass of the oil and then substitute the value of mass in this same formula using the initial density to find the initial volume. So let's solve that to see what it would look like. Now, like we said, we'll use the final density, which is 0.4 kg per meter cube. We're looking for mass, and then the initial volume, the final volume rather, is 20 meter cube. So mass is equal to 0.4 times 20, which is equal to 8 kilogram. So that is the mass of the oil. Now to find initial volume, okay, still using this formula but making initial volume subject of formula, initial volume is equal to mass over the initial density, and you have those values. So 8 kg divided by 0.8 kg per meter cube, and that is equal to 10 meter cube. 10 meter cube is option A. So 10 meter cube is the initial volume of the oil. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 8. all objects, hot objects. Now option A says light energy, and light energy basically is the energy associated with the electromagnetic wave visible light. Now this is the only EM wave that is visible by the or visible to the human eyes. Now heat energy isn't radiated by hot objects in the form of light energy, as not all hot objects, okay, not all hot objects give off light. Not all hot objects give off light, so it is not the answer to the question. Now option B says solar energy. Now solar energy is basically the energy from the sun, the energy given off from the sun, which usually includes light and heat energy from the sun. Now hot objects do not give off, all hot objects do not give off solar energy, because we have said it is only the sun. The sun is the only source of solar energy, this combined, light and heat energy. So it is not the correct answer to the question. Now option C says infrared rays. Now infrared rays, okay, is also an EM wave. It's also classified as an electromagnetic wave, and most of the thermal radiation, most of the red rays is in the form of infrared rays. Okay, so infrared rays is the form in which heat is radiated by hot objects, in which thermal radiation is given off by hot objects. So option C, infrared rays, is the correct answer to this question. Okay, thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Part question 19. If a container is filled with ice to the brim, what happens to the level of water when the ice completely melts? A. The water in the glass outflows. B. The level of water drops. C. The level of water remains unchanged. D. The level of water goes up. So let's picture this scenario where you have a container filled with ice. Let's say ice cubes, okay, filled with ice cubes to the brim of the container, filled to the brim with ice cubes. Now I ask, what happens to the water level when the ice completely melts? How will the water level be in the container? Okay, so basically, to answer this question, we need to know what ice is made up of. Now generally we define ice as solidified water. Okay, so water that has been solidified by the process of freezing. So solidified water, or some will say frozen water. So that is what ice is made up of. Now aside water, ice is also made up of air, okay, either in the form of, or air usually in the form of bubbles. So ice is made up of water and air trapped, okay, within it, as part of it. So in this container containing ice, you have water, okay, as part of the ice, and you also have air as part of the ice. So what happens when it eventually melts is that as it melts, the air, of course, will be liberated from the container, and what you have is the liquid. Okay, so since it's just the liquid you have and not with the air anymore, the water level will be lower than what you had when you had it filled to the brim, because the air component, of course, has been evolved. So the level of the water drops. Okay, so that is option B, as we have established. So the container won't be filled to the brim with water when it completely melts, because the ice is made up of water and air, and the air of course will be given off and you'll be left with just the water. So B, as we have rightly established, is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 20. The small droplets of water that forms on the grass in the early hours of the morning is A, dew, B, mist, C, fog, D, hail. So there's a phenomenon that occurs in the early hours of the morning where you find water droplets on the grass. So we are asked what it is called. So let's look at the definition of each of the options to see which one fits this description given to us in the question. Now option A says dew. Okay, now dew is water in form of droplets, water in the form of droplets that appears on thin exposed surfaces in the morning or sometimes in the evening. Okay, in rare cases in the evening. Now due to condensation of atmospheric moisture. So that is dew. Now option B says mist, and mist is defined as a cloud of tiny water droplets suspended in the atmosphere, or near the Earth's surface. Now option C says fog, and fog is a visible aerosol consisting of tiny water droplets or ice crystals suspended in the air. An aerosol is basically where you have a liquid component suspended in a gaseous component. Okay, so in this case is water droplets suspended in air. Now option D, which is hail, refers to pellets of frozen rain. Now from the definitions we have given, option A, which is dew, we define that as water in the form of droplets. So water droplets that appears on thin exposed surfaces such as of course grass in the morning due to the condensation of atmospheric moisture. Okay, so that basically fits into the description of what we have in the question, as we described it as droplets of water that forms on thin surfaces such as grass in the early hours of the morning, and we explain this phenomenon due to the condensation of atmospheric moisture. So option A, which is dew, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 21. A vapor is said to be saturated when A dynamic equilibrium exists such that more molecules return to the liquid than are leaving it. B, the vapor pressure is atmospheric. C, the temperature of the vapor varies. D, a dynamic equilibrium exists between liquid molecules and the vapor molecules. Now, we're looking at what a saturated vapor is. Okay, so a vapor that is saturated vapor, and a saturated vapor refers to a state where the system, that is the gaseous system, is holding the maximum amount of liquid in vapor at corresponding temperature and pressure. Okay, so in this system, what it entails is that you have the same, or you have a system that contains the maximum amount of liquid in that vapor at that particular temperature and pressure. So if you have maximum amount or equal amount, it means that what is established is an equilibrium. Okay, what's established there is an equilibrium. Okay? So option D says a dynamic equilibrium exists between liquid molecules and the vapor molecules. So option D describes that equilibrium that exists between the liquid and the vapor molecules. So option D is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 22. The pressure of 1 mole of an ideal gas of volume 10 raised to power minus 2 meter cube at a temperature of 27 degrees Celsius is A. 2.24 times 10 raised to power 4 Newton per meter square, B. 2.24 times 10 raised to power 5 Newton per meter, C. 2.49 times 10 raised to power 5 Newton per meter square, D. 2.49 times 10 raised to power 4 Newton per meter square. And we are given molar gas constant as 8.3 joules per mole per Kelvin. Now we are looking at an ideal gas, and we are asked to find the pressure of 1 mole of the ideal gas at this volume and at this temperature. Now we'll make use of the ideal gas equation, and the ideal gas equation is PV is equal to nRT. Now we are searching for pressure, so we'll make pressure subject of formula. Okay, so if this is PV is equal to nRT and you make pressure subject to a formula, this is what happens. So that is P is equal to nRT over V. Okay, so P is equal to nRT over V. Now we substitute our values. N is number of moles, so that is 1. Remember, we said 1 mole of the gas, multiplied by R is the molar gas constant. Okay, so that is 8.3. Now T is our temperature, and our temperature is given to us as 27 degrees Celsius. Now we have to operate in Kelvin, because looking at the gas constant here, what you have is per Kelvin, so you have to convert to Kelvin. So to convert to Kelvin, you say 27 plus 273, and 27 plus 273 is equal to 300 Kelvin. So multiply by 300 over the volume, which is 10 to the power of minus 2. Now this means that P will be equal to 2.49 times 10 raised to power 5 Newton per meter square. If you compute this all together, this is the answer you will get, and this is option C. So option C is the correct answer to the question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 23. Which of the following has no effect on radiation? A. Density, B. Temperature, C. Surface area, D. Nature of the surface. Now we're looking at what radiation is all about. Radiation. And radiation is under heat transfer. Okay? Now, radiation as a method of heat transfer refers to the transfer of heat by electromagnetic waves, and it does not require matter or medium to be present. Okay, so the radiative energy, such as heat in this case, will perfectly pass through vacuum. So it does not require material medium to be transferred. Now it asks which of the following options does not have any effect on radiation. Now option A says density. Now it cannot be, density is not the has no effect. Okay, density has no effect on radiation because, like we said, radiation does not require any material medium to be present. So the density of the material medium does not come into play, as the heat can be transferred through vacuum. Okay, so density has no effect on radiation. Now temperature, of course, has higher effects on radiation, as when you have high temperature, what you have is heat. Okay, and the heat can therefore be transferred through radiation. So a hot surface like the sun, okay, you have transfer of heat via this method. So temperature is not the answer because it has effects. Now surface area and nature of surface go one-on-one, as a hotter surface will be more likely to transfer via radiation, and a larger surface also will be much more likely to transfer heat via radiation. So as you have rightly established, option A, which is density, is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Part Question 24. The wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is its period? A. 1 second, B. 0.1 second, C. 0.5 seconds, D. 1.2 seconds. So we are looking at waves, and we are dealing with wavelength, we are dealing with velocity, okay, and we are asked to find its period. Now we are going to be using two formulas to solve this question. The first formula, V is equal to F lambda, which is the first familiar wave formula, and the second one, T, which is period, equal to 1 over F. Now let's look at the first formula. Okay, so we are going to have to find frequency first in order to find period, because we have to find period, and we are given velocity V, which is 420 meters per second, and we are given wavelength. We are given the wavelength, which is lambda, and that is 42 meters. Okay, so we are given these two. So first we'll find frequency, okay, F, and then we'll now use it to find period, which is T. So making F subject of formula here, F is equal to V over lambda. F is therefore equal to V, which is 420 over 42, and that is equal to 10 hertz. Okay, 10 hertz. That is the frequency. Now, since we have gotten the frequency, let's get the period. Now, period T is equal to 1 over F. That is 1 over 10. So 1 over 10 is equal to 0.1 seconds. So the period is equal to 0.1 seconds. 0.1 seconds is option B, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. The sound of an electric bell dies slowly when air is slowly pumped out from a bottle because A. Sound cannot pass through the bottle, B. Sound can pass through a vacuum, C. Sound needs a material medium, D. The wavelength of sound becomes greater in the bottle. So you have a scenario here where you have let's say you have a bottle with an electric bell, okay, within it, with an electric bell within the bottle. And then when you strike the electric bell, the sound, is propagated. But however, when you pump the air out of it, okay, when air is slowly pumped out from the bottle, the sound of the electric bell dies slowly. So we are asked why this phenomenon. Now, one key feature of sound or sound wave is that sound cannot be propagated through vacuum. Okay, sound cannot be propagated through vacuum. Now this means that sound requires a medium of propagation. Okay, so sound requires a medium of propagation. Now, when you take out the air from this bottle, what happens is that there is no more medium for the sound wave to be propagated. Therefore, the sound of the bell will now die slowly. So the answer to this question is C. Sound needs a material medium. Sound needs a material medium to be propagated. So since the material medium, which is air in this case, has been removed, you cannot hear the sound. The sound cannot be propagated. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. During a thunderstorm, the sound is heard over a long time. This phenomenon is referred to as A. Refraction of sound, B. Reverberation, C. Superposition, D. Diffraction of sound. Now, we are asked what is the phenomenon responsible for why the sound during a thunderstorm is heard over a long time. Now let's look at each of the options and see which one best explains this phenomenon. Now option A says refraction of sound, and refraction of sounds refraction of waves including sound, because sound is a wave, involves change in the direction of waves as they pass from one medium to another. So that is refraction of sound. Now option B says reverberation of sound. Now reverberation refers to the lengthening effect of sound. Okay, this is usually due to many echoes or continuous echo. So this is reverberation, and of course echo is reflection of sound. Okay, now option C says superposition, and superposition simply refers to when two waves add together. And then lastly, option D, which is diffraction of sound, refers to the bending of waves around small obstacles. Okay, so the bending of waves around small obstacles and spreading of waves beyond small openings. Okay, so that is diffraction. Now from all the phenomena we have observed, option B, which is reverberation, refers to the lengthening effect of sound due to many echoes, due to continuous echoes. Now this best describes the phenomenon that occurs during the thunderstorm, because during thunderstorm you have lots of sounds from the rain, from the thunder, etc. You have various sounds, and these sounds undergo reflection, so there is continuous echo, and then what you have as a resultant effect is the lengthening of sound, which is reverberation. So reverberation, option B, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 27. The velocity of sound in air at 16 degrees Celsius is 340 meters per second. What will it be when the pressure is doubled and its temperature raised to 127 degrees Celsius? A. 4,000 meters per second. B. 160,000 meters per second. C. 8,000 meters per second. D. 400 meters per second. Now we are working with velocity of sound in air. Velocity of sound in air. And we are looking at the effect of temperature. Okay? The effect of temperature to or on the velocity of sound in air. Now, this relationship, velocity of sound in air, is directly proportional to the square root of the temperature. Okay? Now, T, of course, has to be absolute temperature, that is in Kelvin. Okay, so based on this relationship, if you have two velocities and temperatures given to you, it will then be V1 over root T1 is equal to V2 over root T2. Okay, so now let's look at the variables we have. Now T1, which is our initial temperature, is 16 degrees Celsius. Now remember, we say it has to be in Kelvin, so plus 273 will be equal to 289 Kelvin. Okay, now V1 is of course 340 meters per second, whereas V2 is what we are looking for. Okay, what will the velocity be when the temperature is raised to? So T2 is now 127 plus 273, which is equal to 400 Kelvin. Now let's substitute these values into the equation. Now V1 is 340 meters per second over root T1. T1 is 289 is equal to V2, which is unknown, over T2, which is root 400. Okay, so V2, so if you make V2 subject to a formula, V2 is equal to 340 multiplied by root 400 over root 289. And if you solve this, complete everything, what you will get is 400 meters per second. And 400 meters per second is option D. So D is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Welcome. I will be answering Jamb 2010 Physics Past Question 28. In comparing the camera and the human eye, the film of the camera functions as the A. Iris, B. Pupil, C. Cornea, D. Retina. Now, there are many comparisons that can be made in terms of similarity in function, okay, between a camera and a human eye. Now, some of these similarities include the shutter in the camera. Okay, the shutter in the camera is usually compared to the iris in the human eye, mainly because of the function or the common function which they perform in control of light. Okay, another part that is usually compared is the lens. Lens in the camera is compared to the lens in the human eye, and this is due to their similar function of focusing light. Okay, another part that is compared between the camera and the human eye is the film of the camera. Okay, it is compared to the retina of the human eye, and this is because of their function in display of image. Okay, and then lastly, okay, so these three basic parts, okay, are compared in the camera and the human eye. Now the question asks us what the film of the camera functions as in the human eye, and we have established it here that the film in the camera performs similar function as the retina in the human eye. So option D, retina, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 29. An object 4 cm high is placed 15 cm from a concave mirror of focal length 5 cm. The size of the image is A 3 cm, B 5 cm, C 4 cm, D 2 cm. Now we are looking at a concave mirror. Okay, so once you see mirror, the first thing to do is to remember the mirror formula, which is given as 1 over f is equal to 1 over v plus 1 over u. Now v is equal to the image distance, u, this is v, image distance. U is equal to the object distance, and f is the focal length. Okay, so from this now you see that we are given the object distance, which is 15 centimeters, and the object height, which we would make use of later, and then we are given the focal length. So we have u and f, but we do not have v. So the first thing to do will be to search for v. Now 1 over v will be equal to 1 over f minus 1 over u, and that is equal to 1 over 5, which is right here, 1 over 5, the focal length, okay, minus 1 over u, the object distance, which is 15. Okay, so this, if you solve this, that will give you, okay, 3 or 2 rather over 15. Okay, find LCM and add that together. That is you subtract this from this, that is 2 over 15. Now remember that 1 over v is equal to 2 over 15. Therefore v is equal to, that you take it the other way, that is 15 over 2. Okay, now that is equal to 7.5 centimeters. Now this 7.5 centimeter is the image distance. Now magnification, okay, to get the size of the image, okay, you use the magnification formula, which is equal to v over u, that is image size over the object size. Okay, so now we have two sets of values to work with. Okay, the first set of values to work with is the distance. So you can say you use the distances, that is this, okay, is equal to this. So like we have established here, the distances, the object and image distances, and the object and image size is what you make use of. So v over u, that is 7.5 over 15, okay, is equal to the image size, which is what you are looking for. Let's call that x, over the object size, which is 4 centimeters. So x is therefore equal to 7.5 multiplied by 4 over 15. Therefore x is equal to 2 centimeter, and x, as you remember, is our size of the image, or the image size. So the image size is 2 centimeter as we have calculated, and 2 centimeter is option D, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 30. An object is embedded in a block of ice 10 centimeters below the plane surface. If the refractive index of the ice is 1.50, the apparent depth of the object below the surface is A 6.77 centimeters, B 7.63 centimeters, C 7.50 centimeters, D 2.50 centimeters. Now we are given an object, okay, which is embedded in a block of ice 10 centimeters below the plane surface. So this is the real depth, okay, of that object. So the real depth is equal to 10 centimeters, and then we are given the refractive index, which is represented by this symbol, refractive index, as 1.50, and we're asked to find the apparent depth of the object, or the way the object appears when you observe it, okay, from the top. So what is the apparent depth? Okay, now refractive index is equal to real depth over apparent depth. So we are looking for apparent depth, remember. So if you make that subject to a formula, apparent depth will be equal to the real depth over refractive index, and our real depth is equal to 10 and our refractive index is 1.50. So if you divide that, you have 6.7, okay, 6.77 centimeters, 6.77 centimeters, and 6.77 centimeters is option A. Option A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 31. Which of the following is used for the correction of short-sightedness? A. Concave lens, B. Concave mirror, C. Convex mirrors, D. Convex lens. So in the question we are asked what can be used to correct short-sightedness. Short-sightedness is also known as myopia. So short-sightedness is when an individual cannot see distant objects clearly because his or her eyeballs are too long and images are formed in front of the retina. So the part of the eye called the retina is where images are formed or are focused to be formed. Now in short-sightedness, the individual's eyeball, okay, let me illustrate it. The individual's eyeball is too long. So let's say if an object is placed here, okay, the image of that object is formed in front of the retina, before the retina. So accommodation does not take place. Now in order to correct this, what is used is called a concave lens, okay, a concave lens or a diverging lens, a concave or diverging lens. Now what this lens, okay, this lens, what it does is to further diverge or push the rays to the retina such that it is focused on the retina. So a concave lens is what is used. Concave lens is option A, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 32. Dispersion occurs when white light passes through a glass prism because of the A. Different speeds of colors in the glass, B. High density of the glass, C. Defects in the glass, D, different hidden colors in the glass. So the concept we're looking at here is dispersion, and dispersion is the separation of white light into its component colors of red, orange, yellow, green, blue, indigo, and violet. Okay, so dispersion involves, or is when white light is separated into its component colors of red, orange, yellow, green, blue, indigo, and violet. Now, this phenomenon occurs or is due to the fact that white light is made up of different colors which travel at different speeds through the glass prism. Okay, so this is what brings about dispersion, because different colors of light, okay, they travel at different speed through the glass prism. Option A says different speeds of colors in the glass, so option A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Welcome, I will be answering Jamb 2010 Physics Past Question 33. When a positively charged rod is brought near the cap of a positively charged electroscope, the leaves divergence will A. Converge, B. Remain constant, C. Diverge, D. Be induced. So this is talking about an electroscope. Okay, an electroscope. Now, this is talking about when you have a positively charged rod, okay, brought near the cap of a positively charged electroscope. So we are asked what will happen to the leaves when a positively charged rod is brought near the cap of a positively charged electroscope. Now, in an electroscope, when a charged rod is brought near the cap of the electroscope without touching it, the leaves normally diverge. Okay, the leaves will diverge, indicating that the instrument is charged. Okay. So what happens when a positively charged rod is brought near the positively charged electroscope is that there will be further divergence. So it will diverge because you have like charges, of course, repulsing. So there will be further divergence. So option C, diverge, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome, I will be answering Jamb 2010 Physics Past Question 34. 3 capacitors of capacitance, 2 microfarads, 4 microfarads, and 8 microfarads are connected in parallel, and a potential difference of 6 volts is maintained across each capacitor. The total energy stored is A. 6.90 times 10 raised to the power minus 6 joules, B. 6.90 times 10 raised to the power minus 4 joules, C. 2.52 times 10 raised to the power minus 4 joules, D. 2.52 times 10 raised to the power of minus 6 joules. So you have 3 capacitors, okay, of these capacitance connected in parallel, okay, and we are given the potential difference and asked to calculate the total energy. Now, the first thing to do will be to calculate the total capacitance. And total capacitance for capacitors connected in parallel, C is equal to C1 plus C2. Okay, in this case you have 3, so C1 plus C2 plus C3. Okay, so for as many capacitors as you have, as long as they are connected in parallel, to get their total capacitance, all you need to do is just to add them up. So in this case, that is 2 plus 4 plus 8, which is equal to 14 microfarads. Okay, so the potential difference is 6 volts. Okay, let's say V, voltage potential difference. Now the energy is equal to half CV square. Okay, so now this is equal to 1 over 2 multiplied by 14. Now we need to find our answer in farads. We need to convert it to farads. So to convert from microfarads to farads, if you do that, what you have is 14 times 10 raised to the power of minus 6. That's how you convert to farads. Okay, multiply by 10 to the power of minus 6, then times 6, the potential difference, 6 square. So all these together will give you 2.52 times 10 to the power of minus 4 joules as the energy stored. So that is option C. So option C is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 35. A cell of EMF 12 volts and internal resistance 4 ohms is connected to an external resistor of resistance 2 ohms. Find the current flow. A 4 amps, B 2 amps, C 3 amps, D 5 amps. So we are given EMF and internal and external resistance. Okay, so this is the internal resistance, and then it was connected to an external resistor. So let's call the internal resistor R. Yes, sir. Okay, and then small r is called, okay, external resistor small r. So let's call our E as the EMF. EMF. Okay, so we're looking for the current flow, which is I. Now using Ohm's law, V is equal to IR. In this case, our V is our EMF, which is E. So E is equal to IR. Okay, so that means I is equal to E over R. Now notice that we are working with two resistors, the internal and external resistors. So our I will be equal to E plus R plus the small r. Okay, so let's substitute our values. 12 over 4 plus 2, which is equal to 12 over 6, and that is 2 amperes. And 2 amperes is option B, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 36. So you have a diagram. The diagram above shows a balanced meter bridge. The value of X is A 66.7 centimeters, B 25.0 centimeters, C 33.3 centimeters, D 75.0 centimeters. So you have a meter bridge, okay, shown here, and we're asked to find the value of X in centimeters. Now the first thing we would need to do is to get the value of R, and to do that, 1 over R, since it's in parallel, 1 over R is equal to 1 over 8 plus 1 over 8, which is equal to 2 over 8. Therefore R is equal to, since this is 1 over R, so that's, take it up, okay, the other way, which is 8 over 2, that is 4 ohms. So that is our value of R. Now in a balanced meter bridge, I over I1, okay, I over I1 is equal to R over R1, where R, okay, where R is equal to 4 ohms, which we just calculated. R1 is equal to 8 ohms, okay. I is equal to X, which is what we are looking for, and then I1 is equal to 100. This is I, and this is I1. So I1 is equal to 100 minus X, right? So we substitute that. I is equal to X, so X over 100 minus X is equal to 4 over 8, okay. So we cross multiply, so 400 minus X is equal to 8X. This is equal to 400 minus 4X is equal to 8X. So 400 is equal to 8X plus 4X. 400 is equal to 12X. Divide both sides by 12. So 400 divided by 12 is equal to 33.3 centimeter, which is the value of X. So X is equal to 33.3 centimeters, and that is option C, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics past question 37. 3 4 ohm resistors connected in parallel have a potential difference of 16 volts applied across them. What is the total current in the circuit? A. 12 amperes, B. 8 amperes, C. 10 amperes, D. 14 amperes. So we have 3 4 ohm resistors, so 3 resistors of resistance value 4 ohm, 4 ohms and 4 ohms, okay, and they have potential difference of voltage of 16 volts applied to them. So we're asked what is the current of the circuit. Now the first thing to do is to get the total resistance, which is equal to R. So for parallel, 1 over R is equal to 1 over 4 plus 1 over 4 plus 1 over 4. That's equal to 3 over 4. So R is equal to 4 over 3, okay. R is equal to 4 over 3. Now V is equal to IR, Ohm's law. So I is equal to V over R. So I is equal to V, our potential difference, 16 over 4 over 3, okay. So that is equal to 16 times 3 over 4, which is equal to 12 amperes. 12 amperes. 12 amperes is option A, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics past question 38. So you have this diagram, okay, displayed here. Now in the diagram above, a 200 watts bulb is lighted by a 240 volt AC main supply. If 1 kilowatt per hour is sold at 14 naira, the cost of keeping the light bulb lighted for a day is A. 192 naira, B. 1 naira 92 kobo, C. 19 naira 2 kobo, or 19 naira 20 kobo, D. 1920 naira, okay. So it's important to note that energy consumed in a setup like this or similar to this is equal to the power multiplied by time, okay. So in this case the power is 200 watts, so the energy consumed times 24 hours, that is 1 day, okay. We ask for when the bulb is lighted for 1 day. at this power. This is the power of the bulb. So 200 watts times 24 hours is equal to 4,800 watts, okay, per hour. 4,800 watts per hour, or watts hour. Now, to convert it to kilowatts, because we are going to be making some calculation in one, okay, which if the we are going to be making the calculations using kilowatts per hour, so we need to convert this to kilowatts per hour. So we divide that by 1,000, and that will be equal to 4.8 kilowatts per hour. Okay, now 1 kilowatt per hour costs 40 naira. Therefore 4.8 kilowatts per hour will cost, that is 4.8 times 40, and that is equal to 192 naira. 192 naira, and 192 naira is option A. So option A is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 39. Power supply is transmitted at a very high voltage and low current in order to A. Increase the power supply, B. Prevent overheating of the coil, C. Make it travel fast, D. Make it pass through the transformers. Now, power is usually transmitted at very high voltage for commercial purposes. Okay, so for commercial purposes, so electrical power is usually supplied at very high voltage but at low current. Now the question is, why is this done? Okay, now usually it is done to increase, or basically it is done to increase the efficiency, okay, of power supply. Now it does this by preventing overheating. It does this by preventing overheating of the coils, okay, or of whatever it is used for transmitting, for transmitting the electrical power. Now the lower current that accompanies high voltage transmission reduces resistance in the conductors. So when resistance is reduced in the conductors, okay, the machine, or the power supply rather, is much more efficient, and this is because heating, or much of the energy, is not lost as heat. So option B, prevent overheating of the coil, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 40. In the diagram above, if the south poles of two magnets stroke a steel bar, the polarities at T and V will respectively be A. North and south, B. South and south, C. North and north, D. South and north. Now this is what is known as magnetization by stroking, and basically this involves making use of a magnet or magnets to stroke a steel bar in order to magnetize it. Okay, so we are asked that if two south poles, or if the south poles of two magnets, this magnet and this magnet, are used to stroke this steel bar, okay, what will be the polarities at T and at V? Now in magnetization by stroking, the last touched pole has a pole opposite to that of the magnet used. This is the rule for it. So in this case, since south and south is used to touch, both poles, so that is the last touch pole, okay, it will have a pole. The pole of those poles at the ends will have a pole that is opposite to that of the magnet used. Now the pole of the magnet used was south and south, so the poles of T and V will be opposite, to that used. So therefore it will be north and north, opposite poles to that of the magnet used. So north and north will be the polarities of T and V. North and north is option C, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'll be answering Jamb 2010 Physics Past Question 42. Two inductors of inductances 5 millihenry and 15 millihenry are connected in series, and the current of 5 amps flows through them. The total energy stored in the inductors is A. 250 joules, B. 50 joules, C. 62.5 joules, D. 500 joules. Now we are given inductors of two. We are given the inductances of two inductors, 5 millihenry and 15 millihenry respectively, and you're also told that these inductors are connected in series, and this current, 5 amp current, flows through them. So we have to calculate the total energy stored in the inductors. Okay, now the first thing you do is to get the total inductance. Okay, and total inductance L will be equals to L1 plus L2. Okay, inductors connected in series. Okay, so that will be 5 plus 15, which is equal to 20 millihenry. Now energy stored in inductor is given as 1 over 2, okay, L I square. Okay, that is 1 over 2 the total inductance multiplied by total inductance multiplied by the square of the current. So that is 1 over 2 times 20 times 5 square, and that will give you 250 joules. 250 joules is option A, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 43. In alternating current circuits at resonance, the angle of lead or lag is A. Pi over 2 degrees, B. 0 degrees, C. Pi over 3 degrees, D. Pi degrees. Now what we are given here is an AC circuit, an alternating current circuit, AC circuit at resonance, and we're asked for the angle of lead or lag. Now take note, we are looking at AC circuit at resonance, and the major characteristic of an AC circuit at resonance is that there is no lead or lag. Okay, so since there is no lead or lag, it means that the angle of lead or lag will be equal to 0 degrees, because we have established that there is no lead and no lag in an AC circuit at resonance. So 0 degrees is option B. Option B is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 44. In Faraday's laws of electrolysis, a graph of mass deposited against the quantity of electricity is plotted. The slope of the graph gives A. the electrochemical equivalent, B. the charge released, C. the current flowing, D. the energy released. So in Faraday's law of electrolysis, we are made to understand that Q, which is quantity of charge, is equal to IT, which is current multiplied by time, and mass, okay, mass is also equal to IT, which is current multiplied by time. Now if you plot these two graphs, okay, if you plot not the two graphs, rather a graph of mass, okay, so M against Q, so graph of mass deposited against quantity of electricity when it is plotted. So we are asked, what does the slope of the graph give? Now if you plot this graph, it usually presents itself as a straight line passing through the origin. This is the origin, so a straight line passing through the origin. This is how the graph usually presents itself. Now if you take the slope of the graph, okay, we're asked what is the slope of the graph. Now the slope of the graph is usually equal to Z, okay, an alphabet represented as Z, and Z is the electrochemical equivalent. So the slope of graph of mass deposited against quantity of electricity is equal to the electrochemical equivalent Z. An electrochemical equivalent is option A. So option A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 45. In a discharge tube, most of the gas is pumped out so that electricity is conducted at A. Steady voltage, B. Low pressure, C. High pressure, D. Low voltage. So we are asked, what is the purpose of pumping out most of the gas in a discharge tube? Now the purpose of pumping out most of the gas from a discharge tube is to reduce the pressure within the tube. Now reducing the pressure within the tube, okay, is done so that the electricity can be conducted at low pressure. So most of the gas is pumped out so as to decrease the pressure within the tube. So within the tube you will now have a lower pressure in the tube. Now this is done so that electricity can therefore be conducted at the low pressure. So option B is low pressure, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 46. The radioisotope uranium-23592 decays by emitting 2 alpha particles, 3 beta particles, and a gamma ray. What is the mass and atomic numbers of the resulting daughter element? A. 91 and 227, B. 92 and 238, C. 227 and 91, D. 215 and 88. So we're asked to obtain the mass and atomic numbers of the resulting daughter element when this radioisotope decays, okay, undergoes this sort of decay, this sort of radioactive decay. Now let's look at what happens, okay? But first, it will be important to note that an alpha particle, okay, is similar to a helium atom, which has mass number of 4 and atomic number of 2, okay? Then a beta particle is similar to an electron, which has mass number of 0 and atomic number of -1, and then a gamma particle is, or a gamma ray has atomic number of 0, okay, atomic number 0 and mass number 0. So it will be important to note these particles, okay. Now let's look at what happens when it decays. So when uranium-235 decays, okay, like we said, the decay involved is 2 alpha particles. So 2, okay, that's like having 2 helium atoms. So we represent that as this, okay, 2 helium atoms. Then 3 beta particles, so 3 electrons, similar to having 3 electrons, okay, and then 1 gamma ray. And then daughter elements, let's call the daughter elements X, okay. So we're asked to find the mass number and the atomic number of these daughter elements X. Now let's look at what we do. Now to get the atomic number and mass number of the daughter element, first we need to get the collective mass and atomic numbers of everything here, of all the radioactive particles, okay, of the alpha, beta and gamma rays, and then subtract it from this, okay, and then what we have left will be the mass number and atomic number of the daughter element, okay. Now for helium atom, 4 is the mass number, and we have 2 of it, so that is for mass number, let's say mass number, okay. So 4 multiplied by 2, that is 8, okay. Then for the electron, that is the beta particle, we have 3 of it, but the mass number is 0, so that is 0. And then for the gamma ray, it is 0, so that is the collective mass number on this side is 8. Now to get for the resulting daughter element, the mass number of the resulting daughter element, you say 235, that is the mass number of uranium, minus 8, and that is equal to 227. So this is the mass number of the daughter element. Now we'll do similar thing for the atomic number. Now for the atomic number for helium, it is 2, okay, that is the alpha particle, and you have 2 of these, that is 2 multiplied by 2, which is 4. Now for this you have minus 1, and minus 1 times 3 is equal to minus 3, and then for this you have 0, so this will give you 1, okay. So 92 minus 1 is equal to 91, so the atomic number is 91. So the mass number is 227, and then the atomic number is 91. So 227 and 91 respectively, and 227 and 91 is option C. So option C is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 48. Transistors are used for the A. Conversion of AC to DC, B. Conversion of DC to AC, C. Amplification of signals, D. Rectification of signals. Now we are asked for the function of transistors. Now it's important to note that transistors are semiconductors with 3 terminals, used mainly for amplification of signals and also voltage stabilization and signal modulation. So transistors have many functions, but among the numerous functions of transistors we have listed 3: amplification of signals, voltage stabilization and signal modulation. So one of the ones we listed is amplification of signals, okay, and amplification of signals is option C. So that is a function of transistors. So C, amplification of signals, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 49. A typical transistor characteristic is represented as, so you have four separate graphs here, okay, A, B, C and D, and we are asked for which one represents the typical transistor characteristic. Now it's important to know that a typical characteristic is ohmic. That means it obeys Ohm's law, okay, and for Ohm's law, for a graph of Ohm's law, what you usually have is V plotted against I, that is voltage plotted against current, and you have that like this, okay. But however, when you have I plotted against V, what you usually have is something like this, okay. So like we said, it is ohmic. A typical transistor is ohmic, therefore it obeys Ohm's law. So this is what the graph looks like when you plot current against voltage, and that is what is seen here in option D. So option D is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2010 Physics Past Question 50. Which of the following is a pure semiconductor? A. Silicon, B. Phosphorus, C. Transistor, D. Carbon. So we are asked for which one amongst the options is a pure semiconductor. Now, a semiconductor is a material, or semiconductors are materials which have an electric conductivity intermediate in value between that of a pure metal, which is a good conductor, and that of a good insulator. So a semiconductor is any material which has an electric conductivity value between that of a good conductor and good insulator. And examples of pure semiconductors include silicon and germanium. So these are the two major examples of pure semiconductors. So we mentioned silicon. So option A is silicon, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers.